All right. Good morning and welcome to the Wisconsin Next Gen 911 PSAP Outreach webinar. We will be recording today's session, so please make sure to mute your microphones to reduce any feedback on the recording. Thank you. My name is Jessica Jimenez, and I am the Next Gen 911 Program Manager within the Wisconsin Department of Military Affairs Office of Emergency Communications. I do just want to thank you all for joining us today to introduce the new statewide contract with AT&T to provide Next Gen 911 services to PSAPs in Wisconsin. I'm sure many of you have heard of DMA's ongoing efforts to plan for implementing this new technology, so we're very excited to finally be able to share more information with you. I am joined today by my co-presenters from AT&T and Entrado, who I will let introduce themselves next. Paul, would you like to start?
Yeah, Jessica, it's Paul Resnick. I'm the public safety specialist for AT&T for states of Wisconsin, Michigan, Ohio. I've been with AT&T 42 years. More than half that time has been spent in the government segment, and the last 16 years in public safety.
Good morning, everyone. My name is Jim Philbin. I'm the AT&T Program Manager for the State of Wisconsin project.
Hi, everyone. This is Brian Bozeman. I'm an Entrado sales engineer. We partner with AT&T on their ESInet product and offering.
All right. So just again, as a reminder, we are recording this presentation for anyone that was unable to join us for one of the scheduled sessions. So just please make sure your microphones are muted. Brian, if you could go ahead to the next slide. I'd like to just kind of start off with a brief agenda. Again, thank you for joining. We have, of course, a lot to cover today. So now that the introductions are out of the way, I will start off the webinar with an overview of the Office of Emergency Communications and the Next Gen 911 program. I'll then pass it back off to AT&T for the remainder of the presentation to cover their ESInet solution provided under the contract. They'll also dive a little deeper into the PSAP deployment options for the statewide ESInet, and then finish off with next steps now that we have the contract in place. Our plan is also to leave plenty of time at the end for questions. Feel free to drop questions in the chat as you think of them, and we can address them at the end. Next slide, please. So the Office of Emergency Communications, or OEC, as I'll refer to it, was established back in 2017 after state legislation was passed to establish a mechanism for implementing Next Gen 911 in Wisconsin. In addition to the NG911 program, OEC does also oversee the public safety broadband program, which helps manage the different public safety cellular options available to first responders. Of course, the WISCOM program, which administers the statewide interoperable radio system with E.F. Johnson. And not on this slide is a recent effort to establish a communications unit team made up of subject matter experts that can be deployed to assist communications needs during local incidents. All of these programs are wrapped up under the Director of Emergency Communications, and the director position is appointed by and reports directly to the Adjutant General for Wisconsin. Our current director is Eric Veal, who also serves as the statewide interoperability coordinator. Next slide, please. So for those of you that may be asking, well, what is NG911? I would like to just give a very, very high level overview before we get into the rest of the presentation. I think that allows for a little bit of level setting before I start throwing out acronyms for you. So NG911 is basically upgrading your existing 911 infrastructure, which is currently TDM circuit-based, into an IP-based environment through what's called the Emergency Services IP-based network. AT&T will refer to it as ESInet, others ESInet, however you would prefer to pronounce that acronym. But basically, by upgrading to that IP environment, 911 will be capable of processing all forms of emergency calls once NG911 is fully implemented. So this could include text messages, which of course you do today, but it's inherent within the network, being able to pass those text messages across that network. And then, of course, in the future, looking at pictures and videos from the public. Of course, not ready for that necessarily from an operational standpoint, but once the standards kind of catch up and there's a need for it, the network is capable of doing that. Because of the overall interconnectedness of NG911, you'll also be able to deliver and transfer calls to another PSAP with location information and other data that still is attached to that call once the transfer is made. This is especially important for PSAPs that deal with a lot of call transfers today. Next slide, please. So now I want to get a little bit into the NG911 program under OEC and some of the overall responsibilities. As I mentioned, OEC was stood up in 2017, which effectively created the NG911 program at DMA. As the NG911 program manager, my primary responsibility is to administer the contracts required for statewide NG911 services. So for now, this primarily includes the new ESInet contract with AT&T. Under the statute, DMA is also required to determine the operational date for each county when looking at NG911 becoming fully operational within that county. So we are currently working on how we would go about making that determination, really based on the statute and how NG911 is defined, and considering, the current NG911 capabilities available in other states today. Some additional program initiatives that have popped up over the years include some overall strategic planning and coordination of NG911 efforts across the state. Primarily working with the 911 subcommittee to develop a statewide NG911 plan that we hope to look at again and update into next year. Administering the federal grants for 911, many of you have probably participated in our federal 911 grant to upgrade customer premise equipment at the PSAP to prepare for Next Gen 911. So we're wrapping up that grant program, and that'll end March 2022. And not necessarily out there yet, but we are looking at establishing a future state 911 grant program. We're going through the administrative rules process for that, and hope to have that out there next year. And then finally, some general reporting on 911 fee usage, NG911 implementation status, and some other 911 statistics, mostly at the federal level. But if there were to be any state level reporting, we would probably fill that role as well. Next slide, please. So how are we doing all of this? I wanted to cover a little bit about our funding mechanisms in place today. We currently have a biennial appropriation that we are using to fund our contract with AT&T. The funding can also be used for that state grant program to PSAPs that I mentioned on the last slide, which will, again, hopefully start up next year, and then for the 911 subcommittee to administer its duties. When I mention we're using the funds to cover the contract or for NG911 services with AT&T, I also mean that the monthly recurring costs for PSAPs related to the ESInet will be covered by the state under that contract. So that includes primarily the core network and connections out to the PSAP demarcation point, which is will typically be in your back room where your customer premise equipment lies, network maintenance and management of the system, as well as the ECATS reporting suite, which will also have a separate webinar series and live demo later in October. We unfortunately won't be able to record that one, but ECATS is offering separate live demos to agencies that are interested and unable to make those other webinars. Next slide, please. All right. Lastly, I wanted to cover the participation agreement, which will be our onboarding mechanism for PSAPs interested in signing on to the ESInet. When I say PSAPs that are interested, I do mean that this system is voluntary for PSAPs to join. Of course, our goal is to have every PSAP in Wisconsin implement Next Gen 911, but we do understand that some PSAPs have chosen to pursue their own paths to NG911. AT&T will talk a little bit later about network-to-network connections for PSAPs that choose to implement separately, or of course for those that stay in a legacy environment for a time. As the mechanism for signing on PSAPs, though, the participation agreement will also outline the responsibilities amongst the three parties involved in implementing the system. So this includes the responsibilities of the PSAPs that are interested in joining the state and, of course, AT&T for providing the services. We are in the process of finalizing that document based on feedback from the 911 subcommittee. So there is more to come on that agreement once it is finalized. I also wanted to note that preliminary discussions can occur with PSAPs prior to signing any participation agreement. This is a lot of information all at once, so please don't hesitate to reach out if you have questions or would like to set up a meeting to discuss further. So with that, this does conclude my portion this morning for the NG91 program overall. So I will pass it over to AT&T to move on with their next topic. Thank you.
Hello, this is Paul. I want to give you a brief description of the system as a service, because basically the state has signed a contract with AT&T to deliver the elements of the ESInet and NG911 as a service over a period of time. The system exists already with a pre-built 6-core nationwide ESInet that's fully functional and has been deployed for a couple of years with a variety of states. It'll include the call routing, resilient call routing services using our IP network, which is second to none, and a routing protocol that delivers from any originating service provider to the PSAP. The calls, whether they're wireline, wireless, third-party, IP, are routed through our network, through our data centers, which identify the PSAP and deliver the call to the PSAP over AVPN. It's also designed to handle a variety of future entrance into the PSAP, whether it's eventually video, real-time text, and whatever else may come up to through the developmental phases. Next. It's based on I3 standards, and the next generation future products or applications will be deployed over the same network. So it includes the IP voice routing or 911 voice routing, required connections, both ingress and egress, data management, and also includes a reporting suite that the state has procured that includes both I3 and your standard MIS. So this can supplement your current MIS package that is likely part of your call handling solution, or replace it depending upon the needs of each individual PSAP. Okay, next, Brian. There's 2 phases of implementation. One is implementation and turnup, and as Jessica stated, that'll commence when a PA is signed and for the service, and then when it's turned up. And that includes implementation, information gathering, all of the steps to get it live and active. And once it's live and active, it'll be turned over to our maintenance and lifecycle management. One of the things that you may find familiar is the 911 Resolution Center. If AT&T provides your legacy services now, will still be in play, and that'll be your first point of contact should any issues occur. It also is important to note that the termination point is basically what you might refer to as the DMARC, and it's inside the customer or inside the PSAP or the host location where the network will terminate for handoff to your call handling system. Next, Brian. That's it for me. I want to turn it over to Brian Bozeman, our Intrado sales engineer. Here's also the smart guy here and very, very technical, and has been active in numerous deployments of this type of service throughout the country. So hold on to your questions till the end. Queue them up if you do, and I'm certain that he'll be able to explain a little more in depth. Brian?
Thanks, Paul, for that. As Paul mentioned, now we're going to start talking about a technical overview of what the solution is. We're going to cover, basically high level, what is AT&T ESInet? How does it connect to the PSAP? We're going to talk about call handling capabilities, and we're going to talk also a little bit about your GIS data. So things to think about when you're joining the ESInet. I'm a very visual person, so I like diagrams. Here's a high level diagram of really what AT&T ESInet and how it connects to both the ingress for the 911 call origination, the OSPs, the originating service providers, all the way down to the PSAP. So if you start from the left to the right, thinking of how the calls come in today in a legacy environment, the calls are coming from the OSPs, they're routed through a selective router, typically down a single trunk group to the PSAP via CAMA trunks, and then the PSAP is bidding ALI for updated location information. So in ESInet and Next Gen Core Services, we're really replacing that function of the selective router and the ALI database with the AT&T ESInet service. In what Paul mentioned is we have 6 cores. If you're looking at this middle section, we have 6 cores geographically diverse throughout the United States that are already up and running. They were built to handle twice the capacity of the busy hour for all of the nation. So if every PSAP in the nation was on the system, we have it built to handle twice that capacity today. Part of that project, since we're already live with the core sites, is really trying to connect to both the PSAPs and get the OSPs to retrunk from the legacy selective routers to what we call our aggregation sites. We have several points of interface within the state of Wisconsin to provide those carriers with an easier, more efficient way to connect. And we're also providing redundancy. Today, most of, if not all of the selective routers in Wisconsin are very single threaded. So when the carriers connect, they connect via single trunk groups to that selective router. We'll have redundancy. So if that one of those aggregation sites goes down or the carrier's trunks go down, they can fail over to that. As far as a call flow goes, once we get to the aggregation sites and beyond, it's an IP call the rest of the way. So the benefits of IP calls are we can really monitor that traffic and monitor those circuits much more accurately than you can for a CAMA circuit. So if any of you guys are familiar with issues with your CAMA circuits, typically the PSAPs in today's world are the first to know. They will report that saying, hey, every 5th call I'm getting static or I'm not, the call quality is bad. In an IP world, we're actively monitoring those circuits from end to end, and we're using what's called a mean opinion score to determine the quality of that call. And if we see that drop below a certain threshold, we can actually reroute the calls using other network and other circuits until we can correct the issue. So on the other side of it is, as Paul mentioned, this ESInet MPLS cloud. It's an AVPN network, AT&T AVPN. We actually use, it looks like a single cloud. There's hundreds of connection points within this cloud. And when we do order the circuits, we make sure that what we call AVPN A and AVPN B, that the circuits are on separate AVPN networks so they don't overlap within that MPLS cloud. And then finally, we'll be installing IP circuits. And kind of what Paul mentioned earlier is those IP circuits terminate at the PSAP or where your call handling equipment is located. For those that are using a hosted call handling, that's where we terminate the circuits at the host sites. And then we use that existing, the call handling use that existing connectivity out to the remotes. But an important thing that we'll talk about a little later is that we're actually installing some very minimal equipment as we can, but some equipment is installed in the PSAP's back room to connect from our ESInet, from those IP circuits, into the PSAP's call handling equipment. So now we'll talk about call handling and specifically kind of where we're at, where you're at, and where we're going. So AT&T has partnerships with 3 of the major call handling vendors that they resell their equipment. So the Atrato Viper, Motorola Vesta, and Solcom Guardian. All of those the CPE products go through what we call the AFU Approved for Use Lab certification program at AT&T. So AT&T Labs, a secondary group, not connected, not directly a part of the AT&T ESInet public safety group, tests all of the new releases from these vendors to validate and certify that they interoperate with the AT&T ESInet. So we'll talk in a few slides about the different options, but I think saying those three are certified and those are the releases, the 5.1 and Viper 7, and for Vesta 7.2, SP2, Hotfix 1, and then the Guardian release 19.2.4 is in testing right now for i3. So Entrado also offers an i3 compatibility testing lab for CPE vendors. So if they're not listed here, these are the ones AT&T does. If you have a different vendor, typically they come to Entrado. We use the same code base that AT&T ESInet uses, and we test them in a lab environment. And we're actively testing with CallWorks, Zetron, Tritech Central Square, Westel, Magicom, Carbine, and Microautomation. So a lot of CPE vendors have come to us to test this, to make sure that we can interact and we're speaking the same language for that i3 protocol. If I did name one of your vendors, feel free to reach out to them. They can always reach out to myself or AT&T, and we can start that lab testing program as well. But really the takeaway here is now is the time to start talking to your CPE vendors. If you're interested or even thinking about going to AT&T ESInet to joining the state's system as a service, now's the perfect time to talk to your vendors. Talk to them about what you currently are capable of on your current CPE, or what it would take to get fully i3 capable on your CPE. Some PSAPs, it's going to be a software upgrade. Some might be some additional licensing fees from SIP licensing fees, and some might have a complete hardware upgrade. But now's the time to talk, because when we, as Jessica mentioned, the participation agreement that kicks off the project, we will have those conversations again. And a lot of times we move in parallel, where the PSAP's doing a CPE upgrade, we're starting to lay the foundation, the network out to the PSAP, and we can coordinate those activities. So again, just talking about what's required, and we have some additional slides that we'll go over and shows diagrams of the configuration. But like I said, we will be providing network termination equipment. That's AT&T provided, that's AT&T managed equipment. So a router, power distribution unit are the minimums. And we'll talk about in the next slide about potentially using the LPG for those PSAPs that aren't capable of IP or i3. But that will be an AT&T technician sent out, kind of closer to the end of the project before we deploy you. They'll be sent out. They'll be installing those routers in the back room or wherever that call handling is located. We'll talk a little bit later about the space required, but one thing to note here is that since we are in your back room, we're going to have to get permission to install that equipment. And typically it's Monday through Friday, 8 a.m. to 5 p.m. And then we would coordinate with you what the best time to come is, and typically sometimes even ship the routers out to your location. You would receive those and then we'd install them. So this is two separate diagrams kind of showing the capabilities of how we can connect to multiple CPEs based on their capability. I'm actually going to start on the right, because the right is where we want to go. This diagram depicts a fully i3 or IP setup as far as call handling in our network. So, if you imagine this board around here, this is the PSAP back room. We would install our routers. The circuits would come into the PSAP location. We install our routers, redundant routers, per CPE. And then there would be a connection point to the call handling equipment. Typically, customers own and install a firewall just to isolate their CPE and other devices from the network, so that we're only allowing our traffic in and vice versa. But we would establish that connection to the CPE. So that's for both i3, and if you're not fully i3 capable, a lot of PSAPs go IP. We call it RFAI or transitional SIP. So you're still using legacy protocols to get your location data in RFAI, but at least your IP. I didn't mention this on the other calls, but one of the things that we noticed a lot was when PSAPs are CAMA trunks take a lot of time to set up. And we saw PSAPs recognize the the calls or setup time much quicker on a SIP call, on a VoIP call, IP call. So that's one benefit. Also that redundancy. You're not having redundant connections from the selective router today. So super big benefits, even if you can't go full I3. The other one on the left-hand side is this legacy PSAP. So we don't want to leave anyone behind. We want to allow any PSAP to join the network, regardless of their capabilities. And if you don't have the funding, or you're in a cycle right now where you have a contract with an existing vendor and it's not time to upgrade yet, for whatever reason, we can install LPGs, legacy PSAP gateways is what Nina calls them. Basically, their function is to convert the IP call back into a CAMA call to be able to deliver to the CPE. So I would assume everyone in the state is currently getting their calls via CAMA trunks from the selective router so they can support CAMA. So we would also install CAMA trunks in the CPE. That is not really the preferred option. But we've definitely done that in the past a lot for PSAPs that just aren't ready to upgrade their CPE. And the last slide is really talking about that hosted call handling. I know some PSAPs in the state of Wisconsin utilize AT&T's CPE host for their location. If that's the case, we've been installing the ESInet circuits at those host locations, so they wouldn't be going in the PSAP's back room necessarily. I've heard other PSAPs in the state have a hosted, maybe a countywide hosted system that has a geodiverse, node A and node B CPE servers and a couple PSAPs back room, and then they have remote PSAPs off of those servers. Again, that's where we'd be installing the equipment. So as part of, and Jim Philbin will go over this later, but as part of the initial data collection, we're going to be asking some of those questions. What version's your CPE? Do you want to wait to an upgrade? Have you talked to your CPE vendor? And then where is it located? Where are we actually ordering those physical circuits to? Next, we're going to talk about the databases, the two different databases that are used for next generation 9.1. The first one is the location database, very, very similar to an ALI. It's kind of the enhanced version of ALI. So MSAG data and the ALI data. The idea here is the carriers, and they're moving to I3, but they're not there yet. So they're still going to be loading their location data, their ALI records, in a location database. For PSAPs that are already on an AT&T system, they use AT&T selective router and AT&T ALI. This migration from the legacy ALI database into this location database is pretty relatively easy, and the PSAP won't have to be involved a lot because we already have your data. For PSAPs that aren't part of the AT&T ESInet, we still will assist you in migrating that traffic. So we'll work with you on reviewing that data, seeing if there's any split rate centers where one rate center, one central office goes to two PSAPs. We'll work with you to load your MSAG into the location AT&T location database, the LDB. And then we'll even coordinate with the OSPs and the legacy database providers to assist in that process. So for a time being, if say you were on Frontier or Lumen's ALI database today, the OSPs are provisioning into that database on a regular basis as their TNs and addresses update. We will work with them to give them permission to start provisioning the AT&T location database, and there'll be dual provisioning for a short period of time before we cut you over, and then they can continue just to load the AT&T LDB. One of the nice parts is if we do have your GIS data and it's ready to go, we can do geocoding of the ALI data. So today, a typical record in the ALI database, 123 Main Street, does not have an associated latitude longitude to it, just because it's a legacy record. We would add an XY to it based on your GIS data. That really helps with more efficient, quicker routing of calls. And then the GIS data. Again, I know Jessica's working with Geocom to do some GIS analysis of your GIS data statewide. Those PSAPs that are ready to deploy with GIS data, we'd love to do GIS data day one. The huge advantage here is now you're doing geospatial routing. So you're using your GIS data and the caller's location to determine the most accurate PSAP throughout those calls. So for a wireless call, and a cell site that borders 2 different jurisdictions. Today, one jurisdiction is taking all those calls and transferring the calls that aren't theirs. In geospatial routing, if we can get that location data quickly enough from the carriers, then we'll route it to the PSAP based on the actual location, instead of having to fall back to kind of a cell site routing. But part of that move for the GIS database is sharing a GIS roles and expectations document. That'll give you ideas of, if you're very familiar with GIS data, but some of the intricacies with how GIS data and 911 play well or work well together. That gives you kind of an idea. We'll do a GIS data readiness just to make sure. NINA recommends a 98% match rate between your ALI data and your GIS data, so that only 2% of the ALI records would fall out. We prefer 100% when we know there's exceptions and areas that can't be corrected, or that there is a need to do that. So part of that is the GIS data readiness. If we do a readiness check and your data is good, then we're ready to load. Another part of it is the GIS data authority will be given permission or given an account and password to our spatial interface. We also call this the EGDMS. That EGDMS is a web portal that the GIS authority for that PSAP would log into and do a upload their GIS data. Because it's a web portal and it's always up 24/7, 365, the PSAP can really determine the frequency of their updates. Do you want to do an update every week? Do you want to do them just when you make changes? Do you want to have a scheduled process? So that's kind of something that you guys also need to think about is, where's my GIS data, and also what are my operational procedures to update my GIS data? The other thing is, we want to keep those in sync with the MSAG. So sometimes at PSAPs, that's 2 different users. Sometimes it's 1 user. But the idea here is if a new subdivision got added, a new addressing got added, you want to update both your MSAG and your GIS data so they match. Text to 911, also, Jessica and Paul mentioned kind of delivering different call types. So, today, typically wireline, wireless, VoIP. Some PSAPs I know in the state of Wisconsin have text to 911 today. The AT&T ESInet can be used for text transport. So typically, if you have integrated text today, you're getting the call from the TCC, and it's probably going over the internet to your PSAP. If not a web portal that you log into that you access your text messages. AT&T ESInet can deliver the text messages, and there's some advantages of that. We're looking at that network, regardless of text or voice, we're monitoring the same way. So you're getting more additional monitoring on your text messages, making sure they're flowing through. Also, if you're a I3 PSAP using geospatial routing, we can basically route those based off your GIS data. So when a text comes in, if we have location, we'll route that to the appropriate PSAP based on that location, not necessarily based on that cell site that's used today. And the last real feature here is the policy routing function. In today's world, if you're getting text messages today and you had to abandon or bug out, you need to contact your GCC provider to have them reroute the calls to a neighboring jurisdiction or turn off text while you bug out. In AT&T ESInet, when you bug out for your PSAP, we'll reroute the voice calls and the text calls. You don't have to contact 2 different entities. The one thing I would mention is that if you already have text or interested in text, definitely talk with your project manager after you sign up about what your capabilities are today or where you want to be. They can work that into the project plan. The other thing is AT&T ESInet is really text transport. And I keep saying transport because that's what it is. It's transport and policy routing functions. But there are processes to enable text, if it's never been enabled. One of those is that request for service to the wireless carriers, telling them you're a text-enabled PSAP and you'd like to receive text calls. The other is talking to your call handling vendor. Some call handling vendor have software fees, maintenance fees to support the delivery or the receiving of those text messages to your CP. So if you're interested in text, again, it's one of those conversations, have it with your CP vendor today. Tell them you're going to ESInet, you're interested in text, and have that conversation. I talked about this a little bit in the beginning when we were showing the high-level diagram of the AT&T ESInet, one of the parts of the project is getting those OSPs, or originating service providers, off this legacy selective routers and onto the AT&T ESInet. I mentioned this, that AT&T has several points of interface throughout the state of Wisconsin. That's a real big key for us because carriers have enough going on. They don't always like to do projects related to 911, as most of you guys probably know. So having local points of interface for them to connect to where they don't have to run long haul circuits and they can migrate makes that much easier. Part of that process that we do when we kick off is one of the first things we get from the PSAP is a letter of authorization, this LOA. This LOA we used for your alley migrations to talk to the carriers on your behalf, but we also use it to talk to the carriers to make this transition. So we will notify them that AT&T is now your 911 service provider. We have your letter of authorization that lets us act on your behalf. And that really takes the burden off you. Now you don't have to coordinate all the carriers moving over. We do it on your behalf. So we try to take all of that burden off you. And just kind of looking at some of the responsibilities here, the big one is you guys provide a letter of authorization. That's done after the participation agreement signed, but that allows us to do work on your behalf. The other thing is, the other major thing here is assist in addressing OSP delays. Sometimes the OSPs are slow to move. Hearing AT&T tell a different OSP to, hey, move it along, let's get these trunks in a little faster, doesn't always go over very well, or sometimes we stall out. Having the assistance of both the state program and the PSAP sometimes pushes them a little faster. So, but for the most part, we are managing this. So we determine the POIs. We work with the carrier to establish an interface agreement, and then they order the circuits to those POIs, and then we do the testing and turn up. So very much done on the side without a lot of PSAP involvement because we know you're busy doing your normal day-to-day. And kind of lastly, Jessica mentioned this. One of the huge advantages of AT&T ESInet is not only are we have done this in the past and the system set up, we've also established network-to-network interfaces. So this network-to-network interface, or NNI that we call it, basically is what Jessica mentioned, is that ability to connect to other networks for transferring of calls. So we know the state of Wisconsin has a lot of states that border it are also on ESInets. State of Michigan, state of Minnesota, soon to be state of Illinois, they're working on their ESInet project. So the idea here is if this was the state of Wisconsin and someone called 911 and the PSAP determined they needed to route it across the state lines or across to another ESInet, we'd use this NNI connection to route those calls so you could deliver the call with the data to a neighboring jurisdiction that potentially you couldn't do it today. The other thing here that we use the NNI for is a connection to the legacy selective routers. So, if you sign up and your neighboring jurisdiction signs up, one of you guys is probably going to go on first, but you don't want to lose that ability to transfer. So we will have connections to the legacy selective router to connect or to send calls to that legacy PSAP until they've migrated over, or PSAPs that never migrate over. So we do have those connections as well. This is a very simple high-level diagram, but there are every line connecting between clouds, OSPs, and PSAPs are redundant connections. But we allow for that transfer. That it's definitely one of those things that, once the PA is signed, once we start doing this initial data discovery, this is where it's your chance to tell us, who do you transfer calls to today? Who would you like to transfer calls to in the future? Obviously, once, if a PSAP's on the AT&T ESInet, they could technically transfer to any PSAP that's on the AT&T ESInet. But we like to verify which PSAPs you want to transfer calls to, so we can pre-provision that ahead of time, to enable successful transfers. And again, we don't want to take away any current capabilities you have. We just want to enhance them and fix some problems that are out there that we know that are out there today. That's the end of the technical overview. I'm going to turn it over to Jim Philbin, and he's going to talk about implementation and turn-up.
Thanks, Brian. Good morning, everyone. If you can go to the next slide, please, Brian. So at a high level, and Brian touched on this, and so Jessica, but after the PSAP has completed their meetings with the account teams that are involved from the AT&T side, participation agreements are signed and countersigned by all parties. We walk into starting project kickoff call meetings with each individual PSAP, and in those meetings, we start to walk through some of the roles and responsibilities of the PSAP and the expectations from an AT&T standpoint, working along with the PSAP itself. Part of that, those discussions include surveys, both on the PSAP side as well as from the AT&T technician side. Brian, can you go to the next slide, please? So there's a few project phases that are included in the deployment for the ESInet. There's about 5 that we'll go through. Touched on the data gathering portion of it, that each PSAP is going to be responsible for themselves, as well as work with the AT&T technicians and project manager that will create a project plan. And in that project plan, it'll include the design of the ESInet for your specific PSAP. That will include the network components as well as the CP that you currently have, as well as additional CP that might be needed and or upgrades, and Brian touched on that, so did Paul earlier in our conversation. Once everything has been configured and completed, we walk into the deployment phase, in which a cutover plan is created via your project manager and the PSAP. That is for the day of deployment. Once the PSAP has been deployed, there's a meeting, service management meeting that will occur to turn the project over to the AT&T Resolution Center, as well as a service management member. I believe Lisa Wharton is that person. And then going forward, if you had any issues or problems with your PSAP, you would work with the 911 Resolution Center and or Lisa Wharton. Next slide, please. So now we'll get into the weeds a little bit. Again, high level though. Customer responsibilities, really PSAP responsibilities. We'd like to have a point of contact that will work with our AT&T project manager that will represent the PSAP. That can be an IT coordinator, any person that you would feel best fits that role. It can be more than one person as well. The responsibilities from a PSAP standpoint, and Brian touched on it, we have a template that we give our PSAPs to walk through exactly what CPE they have, how your call setup is working today, how would you like it work tomorrow, once the ESInet has been deployed. And it also gets built into that project plan that I had mentioned. There will be weekly status meetings, and we would like that point of contact to attend these meetings. Again, you can add or subtract from these meetings, so the more the merrier, in my opinion. Each meeting will also include the vendors that are involved with the project itself. Any new camera trunks or network that needs to be completed, that will be worked with your project manager as well as with the PSAP itself. Brian, next slide, please. From the AT&T side, there will be a designated AT&T project manager that is assigned to each PSAP. They will be conducting project kickoff calls. They'll be providing a contact list that will include emails and telephone numbers, as well as an escalation list. The reason for the escalation list, and it's not always an escalation, but in case someone is tied up or busy or on vacation, will be a list that will offer different people that you can contact in case you have any questions along your project timeline. The project plan that will be created within the PSAP and the project manager will include a specific timeline of events that will take place throughout the project. They'll included in that timeline will be project site requirements that will need to be met. You'll also receive site drawings for each individual PSAP, as well as a number of different surveys that will be completed from the AT&T side and the Intrado side. Next slide, please. Test and turn up, which is the most exciting part of your project. To get to this point, after your PSAP has gone through all the configurations for your equipment, we work on what's called an operational readiness testing plan. This ORT is designed to facilitate 911 calls into your current PSAP on a test basis. The reason for this, we want to make test calls through the ESInet that is going into your PSAP that will facilitate a 911 call. Within that 911 call, there are a number of different scenarios and test cases that will be walked through and tested. For instance, transfers to all the PSAPs that you currently transfer to, three-way calls, a number of different ORT plans. These plans will be shared with each PSAP so they understand what is being tested and why it's being tested. The reason for going through this process is to ensure that when we do deploy on the day of cut, there are no issues. We want to make sure that it is a smooth transition and that there are not one issue that will come up on that day of cut. When we get to the cutover day and it has been agreed upon between the PSAP and the AT&T network team, usually we cut around 9 a.m., 10 a.m. Again, it's up to each individual PSAP in their schedule. That portion of the cutover is completed within, I would probably say the cutover literally takes about 2 minutes, if that. But after that has been completed, all those operational readiness tests that we completed for testing are now implemented on your live system so that we can again assure that there is a smooth transition without any issues. And that includes making additional test calls with third parties as well. Once that has been completed and the site is fully cut over that day, we let it soak for at least 2 weeks. Once that soak period has been completed, we then turn it over to the service management team along with the 911 resolution center. And we also have an acceptance document that will be signed by the PSAP itself along with the AT&T project management team, and copies of that document will be sent through to Jessica's team. And that is the completion of the test and turn up for the service. Brian? I'll turn it back to Paul, I believe, for the recap.
Talking to mute, sorry. The lot of information being thrown at you, and again, we're open for further discussions. And once the PA agreement is done, we can get moving forward. So basically, in summary, the software as a system is a managed service provided by the state of Wisconsin through AT&T. It provides NENA i3 ESInet and next generation core services to replace your existing legacy selective router and alley connections. It also includes a reporting tool for both PSAP management information as well as i3 reporting. It's configurable to allow you to join at a depending upon your CPE readiness and GIS capabilities, and it's completely managed from cradle to grave through AT&T's program management. So the next steps, as Jessica said, we're working on the participation agreement, and once that's finalized, it'll be dispersed to the PSAPs for consideration and review. Once it's signed, the state and the AT&T have to countersign it. We get a kickoff project meeting going. We discuss the status of the GIS and then initial discovery survey, which will detail your CPE and your site readiness. Upon a site survey, which will be conducted by an AT&T technician, it'll look to see, do you need anything? In most PSAP environments, that's very, very unlikely, other than perhaps some additional electrical outlets or so, but it's still something that has to be reviewed. And then we move forward once the work is complete to implementation and turn up. Okay, next slide, Brian. This is a list of the contacts on the AT&T team. Mark Rao is likely on the call, but he's replacing Bob Grebbins. If some of you know Bob over the years and is his role as a technical sales consultant in the state. You've spoken with Jim, myself. Kate Icavelli is the service manager that'll be overseeing, once the system is cut over. And Brian Bozeman, our sales engineer, and the good old resolution center, which will still play a role as a point of contact to initiate any service requests and escalations. And I think that's it. And we'll turn it back over to Jessica for summation. I think that hopefully there's a few questions that need to be addressed, and we'll do our best to get those answered.
All right, thank you. Yes, I have been monitoring the chat. I haven't seen any questions pop up, but feel free to drop those in there. Also, you could come off of mute and ask them directly. All right, quiet group. Last chance. Otherwise, I don't know if AT&T had any last minute comments. It looks like we do have a question coming in though. How does the ESInet transfer to non-ESInet PSAP? So Brian, if you want to take that.
Yeah, definitely. No, good question. In an ESInet to ESInet connection, and I'm not answering your question directly. I'm going to talk about the ESInet to ESInet connection. We do have that in and I between the two ESInets, and we can transfer, the calls, the voice, along with the data. To a non-ESInet PSAP, there are a couple options. Worst case scenario, we do have connections out to the PSTN, so we could transfer it to a 10-digit number if for some reason there was a PSAP that you would by no means ever want to transfer calls to. The other way, the preferred way, is to transfer the calls to make sure they come in as a 911 call. So if you're transferring to a legacy PSAP, we'll establish connections to that legacy selected router. We will do a transfer. We'll send the voice. With the legacy PSAPs and the legacy selected router, typically you have to dual load those ESRKs knowing that you're going to transfer these calls because they're using the legacy selected route or the legacy PSAP. Typically, not always the case. If they're an AT&T PSAP, it's a little easier. But if they're on a what I'd consider a foreign non-AT&T alley database, then we have the dual loading of the ESRKs to accommodate the abilities to dip for location data. But we would establish those connections to the legacy selective router as part of the initial project and turn up to make sure that you can still transfer calls to those PSAPs. And what we found, I'll go a little deeper, what we found is that some of the PSAPs had historically not been able to transfer calls in between their neighbors, if their neighbors were on a different selective router or a different system. That should not be a problem in the ESInet. Yeah, and yes, you're right, Sue. We can definitely transfer to PSAPs, whether they're on the ESInet or not. We don't want to take any functionality away from you guys today. We just want to enhance it.
Yes, good question. Looks like the next one is there a canned participation agreement letter? If so, where do we find that? So yes, we are working on finalizing that participation agreement. We hope to have it sort of be the same across all PSAPs, just for ease of access, not wanting to negotiate with, potentially 100 different agencies for that. But once that is finalized, we will definitely get a copy out to anyone that would like to review it. And of course, any preliminary discussions, we can kind of go through the participation agreement as well before any signatures happen. So once that does get, I'm hoping by next week, fingers crossed, we'll have most of that finalized and we can get a copy out to everyone. All right, you're welcome. Any other questions in the chat or coming off of mute?
You want me to answer that one, Jessica?
What is
As
the
far as
time frame? Yeah, on average for, getting a PSAP on board.
Yeah, I mean, if that's your question, Eric, about kind of the time frame that this takes, I'd say 6 months is what we're shooting for or striving for, earlier if we can. A lot of it depends on the initial conversations we have with a PSAP, right? We will base that schedule, and I think Jim mentioned it. We kind of build individual schedules for each PSAP, and a lot of those schedules are based on how quickly can we get the initial data collection. The circuits are a very long pole in the tent as far as the timeline goes. Circuits take a while. Whether or not you're upgrading your CPE can impact it, and also your GIS data. And again, we can deploy you a variety of methods, but we want to get you as far along on the spectrum as we can to get you as most advanced technology as possible. So I'd say simple answers like 6 months to sometimes 9 months for the initial PSAP deployment. And then we're also migrating carriers in the background, so that sometimes takes longer. But that's kind of the roundabout. And I'd also say, if you're interested and you're not ready to, your CPE is not ready, there's no harm in signing a participation agreement and starting the project. We can get you in the line of all the other projects and line you up properly. So I would say, if you're hesitant about signing a participation agreement because you don't know when you'll be ready with your CPE, we can work that into the timeline. So, the earlier we start these discussions and these surveys, the better. Hopefully that helps, Eric.
Okay. All right.
And
the next question. Go ahead.
Sorry, Jessica. I can answer Sue's question about the trunks play a role in ESInet. So we are basically replacing all of your trunks from your legacy selective router as part of our project. So you will have connections from our ESInet to your CPE, but preferably, as long as your CPE can handle SIP, we won't have any kind of camera trunks, and there definitely won't be any camera trunks ordered from our system. When I say trunks, I'm talking about from that LPG to your PSAP, but preferably we go IP. Once we deploy, then you can really we'll work with you after that soak period to let you know we're done with that soak period, and then you can contact your local LEC, your local 911 provider that's providing the legacy, and they can disconnect those circuits, those camera trunks and those alley circuits. So they will not play a role in the future. We will be replacing them. Good question.
Yes. All right. Any other questions? We do have plenty of time, so feel free to drop any in.
And Jessica, I know it came up on yesterday's call. If there aren't any more questions, I can always review kind of some of the minimum site requirements. That might spur some questions.
Yeah, that's a good idea. I think that is really important from the PSAP perspective, just to kind of get a general idea of what the expectation would be from their, for their sites.
So we talked, I think Jim and I both, and talked about, kind of one of the steps as part of the project is a initial data discovery survey. And then there's another one called the site survey. And the site survey is actually done by AT&T. An AT&T technician will come out. They have a checklist to follow to make sure that there's enough room and the necessary requirements to support our equipment in your at your facility, or the facility wherever your call handling is located. So a couple of those requirements, just general facility requirements. We want a secured, safe location to store this. We don't want this to be in the middle of a room. Typically, this would just be in your equipment room, right? That has adequate security to prevent theft of computer equipment. So typically, if you have your CPE in your back room, that's the same place we've put ours. One of the things, the necessary consent from the landlord, building owner, mortgager, we basically just need permission to be on the site and install our equipment. So if that's required, some PSAPs have a CGIS requirement to get into their back rooms. We'll make sure we have a CGIS certified technician. But whatever steps are necessary to get approval to install our equipment where those circuits are terminated in your back room. 24/7 access for problem isolation. Again, we'll go through some initial contacts and who's your site contact and who do we contact if we need access. If, say, we had, so for some reason, a router failure, we would need to know how to get into your location or who can escort us through your location to maintain that equipment. And then some of the more technical requirements: a clean, dry space, a space 48 inches by 19 inches by 32 inches of floor space. We're basically, if you allow us and if there's enough room, we'll install a locked cabinet, a server cabinet in your back room where we'll put our equipment. If for some reason there's not enough space, we can use a pre-existing rack if you have one, and we just need 12 contiguous RUs of rack space. So just 12 RUs of rack space that usually is sufficient for our equipment. And then power and HVAC. Power is obviously important. Those routers need to be plugged in somewhere. So 2 dedicated 110 volt 20 amp feeds are required. As Paul mentioned, this is probably the biggest hangup for 90% of PSAPs, and typically it's not a big deal. But if you don't have enough power outlets for us to plug our power distribution unit in, our rack into, then we're going to need those circuits. So that's typically something that we again, Paul mentioned, and I think Jim mentioned. We do that site survey. The technician comes out, and then we provide the PSAPs with a remediation letter to say, here's the things that need to be corrected before we can install our equipment. And typically for this, like I said, this one is either getting someone at the PSAP or a local electrician just to run additional circuits. And then HVAC is always pretty important. If you got equipment in your back room, we just want to make sure it's going to support our equipment. That you have the HVAC systems that can keep the temperature consistent and the relative humidity down, and any surge lightning protection. So those are a couple of things. And again, that's kind of something we would provide as a remediation to the PSAPs if there are any steps needed. And then while we work the project, order the circuits, the PSAP would work on their remediating their backroom issues, if any.
Very good. We did get a question that came in while you were chatting. How are we to handle a geodiverse CPE deployment? Will this implementation include replacing 911 infrastructure at both of our sites?
Right. Good question. I'm going to go back to one of the diagrams. We do, sorry, it's a lot of clicking through. Sorry for people watching the screen. Almost there. But we do want to provide connectivity to both your, if you have a geodiverse call handling system, we want to provide connectivity to both those facilities. This is one of the ways we can do it with redundant circuits at each location. I think typically if we didn't know about this in the RFP, that we didn't price it accurately, but nonetheless, we would install redundant connections from one side, and then we'd use your backhaul network to connect between those two. So we've done this several times. We're actively deploying this in Texas, and that's their typical setup is what they call the Council of Governments, the COGs in Texas, most of them have a hosted geodiverse system, and we install circuits at each of the different host locations. And then we use the existing network between the two nodes for any failovers. And we test that failover as part of our deployment. So we make sure that works, as part of the test and turn up.
All right, very good. Looks like you answered the question. Any other questions? We do have until 10:30, but of course we can always end early. We do want to make sure you had enough time to ask any questions you had. are these slides available for download? So yes, we are recording this session. So I will have a recording that I'll distribute out to everyone on my distribution list. And then we did have some issues yesterday with the slides advancing. So I will be working on a public version of the slides that will come with the recording. All right. Any last questions? Of course, we are definitely willing to meet one-on-one with you and your agency to answer any more specific questions. Of course, every PSAP is different, so we understand the deployments will be a little bit different for each, so you may have more specific questions to your facility. So if there are no other questions, I don't see any coming in. I just want to thank you again for joining this intro webinar. We understand this was probably a lot of information, so please don't hesitate to reach out. AT&T did have their contact information up, and you should all have my email address, of course. I do try to limit my emails to you all, but sometimes it can't be helped. So anyways, just want to let you know to have a good rest of the day, and thank you again.
Thank you.
Thanks, Jessica.